today. So we're going to talk about infinite limits. Infinite limits are where you have vertical asymptotes. Now remind me, how can I find a vertical asymptote?
Set the bottom equal to 0.
Yes, it set the denominator equal to 0.
Like, I don't want to do notes.
All right, after you set the denominator equal to 0, you have to make sure you've canceled out your common factors first. So if you still have your common factors, those are not vertical asymptotes, just whatever is left on the bottom. All right, so that's how you tell where your vertical asymptotes are. Now, when we're doing infinite limits, when you directly substitute, and you substitute your x value into your limit, and you get a number divided by 0. All right, not 0 over 0, another number divided by 0. That's how you tell that you have a vertical asymptote. If you have a vertical asymptote, your answer is either going to be infinity, negative infinity, or DNE. Those are your only options. All right, you do not have any other options. So when you look at my little flow chart over here of limits, right, you're approaching a number. You directly substitute. You get a number over 0. It has to be a vertical asymptote, which means your answers are either DNE, infinity, or negative infinity. What happens if you directly substitute and you get 0 over 0?
Then it's indeterminate.
Indeterminate, and you got to keep going, and you got to do one of these other things down here that we talked about.
Easy.
All right, so if you get 0 over 0, that means you have to keep going. And then when I'm talking about the answer infinity or negative infinity, that is a more descriptive way of saying does not exist. Technically, infinity does not exist. It's more of a concept. But we want to get more descriptive.
Yeah. What's the base
So
number?
like 900 trillion.
What's the base number you know?
Infinity.
What is it?
All right, but infinity is not technically approaching any specific number. It just means it's going on forever and ever and ever. So that's why it doesn't really exist. But we will get more descriptive when we're talking about our limits, and we will say infinity or negative infinity. And then I don't know if any of y'all have seen Mean Girls, but this is the problem in that Mean Girls mathlete competition that she goes, the limit does not exist, right?
Yeah, I got you.
Just like that.
That's what you're putting down right now.
That's a good movie.
Okay.
Why you're
What's your
lying?
cherry vanilla ice cream, bro?
All right. So what we're going to do is we're going to consider a number really, really close to C, which C is any number. We're going to consider a number really, really close to it on the left side, and we're going to figure out if my answer is positive or negative. If it is positive, it's going to go to positive infinity. If it's negative, it's going to go to negative infinity. Same thing on the right side. If it's, you're going to think of a number really, really close on the right side. If it's positive, you go to positive infinity. If it's negative, you're going to go to negative infinity. If the left-hand limit and the right-hand limit are the same thing, then we can say that the limit is either going to be positive or negative infinity. If they are different, then it would be D and E. Okay? Now, the way I set up these examples, it is the same function across the board here. I'm going to start with the left-hand limit, then I'm going to find the right-hand limit, and then I'm going to say something about the limit. Okay? So, first step, directly substitute. When I directly substitute 1 into here,
No, it's a number over 0.
1 over 0.
Is that not
It's a vertical asymptote.
Wait, what?
Are you not paying attention?
No, I guess not. Dude, I just don't get the note ever, to be honest with you.
One.
Okay.
So I'm at 60.
All right, so I have a vertical asymptote at 1.
Sorry.
Because I have a number over 0. Now, I want to determine whether the left-hand limit is going to shoot up to positive infinity as it approaches the asymptote, or it'll shoot down to negative infinity as it approaches the asymptote. So what I'm going to do is I'm going to think of a number really, really close to 1 on the left side.
Like if you're on the calculator portion, could you just like plug that in?
Yes, but these would probably be non-calculator. All right, so like 0.99. Now remember, you get 1 over 0. what I'm trying to determine is if this is a positive 0 or a negative 0.
It's negative.
So when you think of a number really close to 1 on the left side, like 0.99, and you plug in 0.99 here, 0.99 minus 1, is that positive or negative? It's negative. So this is a negative 0.
It's not really 0. It's just like so close.
Yeah, it's so close to 0. It's like 0.00000, but it's negative. Now, a positive number divided by a negative number is going to be a negative. And remember, my options are either infinity, negative infinity, yes, or D and E.
Easy.
So your option is positive infinity, negative infinity, or D and E. So all I care about is whether this bottom number is a positive 0 or a negative 0. And that will tell me which infinity I have.
Okay.
All right, so let's try the right side.
Yeah.
So when you're thinking of a number on the right side of 1, what would that be?
1.0000.
Yeah, 1.01 or 1.001, doesn't matter, but something on the right side of 1. So when I directly substitute that in here for x,
It's positive.
it's positive. So I get 1 over a positive 0, which is going to go to positive infinity.
And then they're different, so the last one's D and E.
Right. So because the left side is going to negative infinity, the right side is going to positive infinity, what can I say about the limit?
Not exist.
It does not exist.
Which makes sense because there's a D and E.
How is infinity?
Because they don't exist. How about instead of making beats, you listen?
All right.
Maybe the beats. I'll figure out my own work.
All right, so hold on. So you can kind of look at see what it looks like graphically. Here's my graph. I've got a vertical asymptote at 1. The left side is going down to negative infinity. So the left side's going down to negative infinity. The right side is going up to positive infinity. And so if you're talking about this limit, it doesn't exist because this side goes down and this side goes up. Irrational. Okay.
With the beats, I'm trying to listen, guys.
All right, 29. Shh. So we're going to do the same thing. It's still set up the same way. I got the left side, the right side, and then the actual limit. So first step is to directly substitute in. When you substitute in, you get 1 over 0, which tells me I have a vertical asymptote. Where's my vertical asymptote at? 1. Okay, now if I'm thinking of a number really close to 1 on the left side, 0.99. And I plug that into here. So what is 0.99 minus 1? Why is it positive?
Because it's squared.
Because it's squared. So squared will make everything positive. So this guy here is going to be a positive 0. What else will make everything positive?
Square root 4.
Absolute value.
Yes, absolute value.
That's still a thing.
All right. So this answer is going to positive infinity.
So is the other one.
Yeah, so when you see this and you directly substitute your guy in and you get 1 over 0, you know it's an asymptote, you know it's one of those 3 options. If you see a squared on the bottom, you should know that that's always going to be a positive 0. And so you don't have to do a lot of work. You can kind of do it in your head and just know that they're going to go to positive infinity, which means that the limit as x approaches 1 is going to be positive infinity.
I'll play with my mind. I'll probably think that.
Okay. On 30, I forgot to put negatives on these guys, so make these negative 3x's here and here. So they're all the same function across the board.
It is not.
All right.
1 over 0.
When you directly sub in 2, you got to put it in for all of the x's. What are you getting on top? Negative 6. And what are you getting on bottom? 0.
Or 0. My bad.
From way down to
All right, so where's my vertical asymptote at? X equals 2.
Do you have to put VA at 2?
because
I think on the homework I do, but if it was the AP test, no. But sometimes the AP test will give you this limit, and it'll ask you something about the vertical asymptote. Yeah.
So it doesn't matter what the numerator is. Like if it's over 0, it's going to be vertical asymptote.
Yeah. Now, the numerator is going to matter in this case because we got to consider the sign of it. When you think of a number on the left side of 2, that's like 1.9, right? All right, now the top is -6. I don't need to worry about the top. It is -6. I have to consider it, but I don't need to mess with it when I'm thinking of, is it going to be positive or -0? So when you plug in 1.9 here, is that going to be a positive or a -0 on bottom? A -0. So this is where the top matters, though. -6 divided by a -0 is going to be positive infinity.
Yeah.
All right, so that's where the top number is going to matter.
That one's negative.
Yes, and so then on this one, when you think of a number like 2.1 and you're plugging that in, you're still going to get -6 on the bottom, but you will get a positive 0, or I'm sorry, on the top. -6 on top, but you'll get a positive 0 on the bottom, which will bring you to negative infinity, and then the actual limit is D and E.
If they don't match, it's D and E.
Yep.
If they do match, it's whatever it is.
Yep.
Got it.
Okay,
Okay, these are pretty.
I'm going to save the trick for the end. I want to go down to do 33 real fast. All right, so on 33, most of the time actually, it's going to be easier if I factor this guy to try to simplify it, especially when you're trying to decide whether it's positive or negative.
2/0.
So what it is, it is going to be 2/0.
2/0.
You're welcome, John. Thanks for
Okay,
And you know,
what multiplies to give you 16, but adds to give you -8?
X minus 4.
X minus 4 and x minus 4. Shh. What is another way of writing x minus 4 times x minus 4?
X minus 4
X minus 4 squared.
squared. And so there's a square at the bottom, so it's just positive. The numerator is positive.
Yes, very good.
Infinity.
So, because the squared on the bottom will always make this guy positive, I know the bottom, no matter what, is always going to be a positive 0, but make sure you are also accounting for the top. When you plug 4 into the top, what number are you getting? 2. So it's going to be positive. What about the right side? Will it change? Nope, because the squared will still keep it positive on the bottom, and the top will still be 2. So I can say that the limit is going to be positive infinity. Okay, so factoring sometimes helps see what's happening with the signs a little bit easier than keeping it in a trinomial.
so really you only have to like write it. Actually do plug once.
Yeah. If you can do it in your head, you don't have to. This is like going to be a multiple choice question on your AP test. It won't be a free response. So you can kind of do those in your head after you factor and stuff. Okay, let's look at 31. When I directly substitute 0, what is 2 minus 0?
2.
Yes, and then sine of 0 is?
0.
0. So you're going to get a VA at 0. All right, so I've got to think about the limit as x approaches 0 on the left side.
Or wait, negative point.
Like 0.01.
0.01.
Yeah. All right, so the left side of 0, it's smaller. We want the numbers that are smaller.
Top is still positive.
All right, so let's look. So we're talking about the unit circle. So the numbers that are smaller than 0, is that going to, like negative 0.01, is that going to go down here in the fourth quadrant, or is that going to be up here in the first quadrant?
Down.
Down. Smaller than 0 is going to go down. Negatives go backwards, right? So I know I'm going to be over here in this quadrant
But it's sort of
for the left side. And we're talking about sine. Is sine x or y? Y. Is the y value down here positive or negative? It's negative. So we have 2 over a negative 0, which is going to be negative infinity.
You get that, Weston? Yeah, I did actually. This is positive infinity.
Yes. And so then, I don't know why it's doing that. On this other one, same thing. Here is 0. A number on the right side of 0 would be like 0.1. So like bigger than 0 would be in the first quadrant, which the sign values are positive. So you would have 2 over a positive 0, which would make it positive infinity. Does that make sense?
yes.
So then I can say that the limit as x approaches 0 is D and E. Okay, one more. Something weird happens with cosine.
Pulling up the trick plays on me.
Yep. All right, last one. So we're plugging in pi over 2.
Pi over 2.
Negative 2 times pi over 2 plus 1 over, and then cosine of pi over 2. All right, what happens with my 2's here? They cancel. What is negative pi plus 1? So let's kind of just guesstimate. What can we guesstimate pi to be?
4.34. Or negative 4.34. No,
Go.
negative 2.34.
You're so close. Not 3, 4.
3.1?
3.1.
So pi is what? What decimal? 3.14.
This is pi followed by.
So negative 3.14 plus 1,
You can leave, bro.
2.14.
I'm stuck in here.
Does that make sense?
Yes.
Okay. So on top, I know it's going to be negative. You don't have to get that decimal. As long as you know that negative pi plus 1 is a negative number, that's all that really matters. So on top, I have a negative number. What's cosine of pi over 2?
Where's pi over 2 at?
Yep. Tell me, where is pi over 2?
It's
At the top.
That's X.
Mhm.
0.
0. All right, so we got to decide, is this going to be a positive 0 or a negative 0? So on the left side of pi over 2. So the left side of pi over 2, that's going to be where the numbers are smaller, right? Because if you're talking about a number line, the left side of pi over 2 are smaller numbers. Does that make sense? So where are your radians smaller? Over here or over here?
On the right.
On the right. So it's weird. So the left side,
It's positive. Because it goes like.
'Cause it goes
from
0.
all around the circle is 2
Yeah.
pi. So it gets bigger as it goes left. Or
yes.
as it goes counterclockwise.
So it's, yeah, because we're going counterclockwise. So it's backwards. So when you're talking about cosine, it's going to be backwards. So the left side is really on this side. So the cosine values, are they positive or negative?
Positive.
Positive.
Yeah, positive.
So we're talking about negative 2.14 over a positive 0, which would be negative infinity. All right, so that happens with cosine because of the way you move around the unit circle.
I like that.
But then it's the opposite.
Yeah.
Positive.
Yeah.
Okay.
This one's positive. infinity.
Yes. So on this one, we're still talking about this point, the right side of pi over 2, which is going to be when the numbers are bigger. So this is the right side of pi over 2. And so the cosine values here are negative. And so then you get negative 2.14 over negative 0, which would be positive. And so then the limit does not exist.
Okay.
So it's just it's just different. Just a weird lesson. Tomorrow's also weird.
That was not bad.
Trick.
No.
Do you want?
We don't have homework, right?
Yeah, you do.
Say your
Back to-
teacher
it's back
gets
there.
you back up.
All right, so for your homework. All right, hold on. Focus in for just a little bit longer. I'm almost done. On 1, 2, and 3, it is just the right-hand side, the left-hand side, and then the right-hand side. It's just the specific side that it's talking about. So your answers on 1, 2, and 3 should either be positive infinity or negative infinity. It's one of those options. You've got a 50-50 shot. On 4, 5, 6, and 7, on these bottom 4, you are finding the actual limit. So you have to consider the left and the right side.
So it's
Okay.
like what?
So yeah, so like we were, you do the left side, the right side, and then the limit. If you can do it in your head, so for example, if you see a squared and you're like, okay, I know the bottom is always going to be positive, so it's going to do that. You don't have to show a lot of work. I'm more concerned about if you can actually figure out the answer. The work here is, it's going to be on the multiple choice part of your test. It's not going to be on the FRQ.
Yeah, but I
So-
don't think there's any square. It doesn't really like it.
I think there is one if maybe you factor. Maybe, I can't remember.
Where on
But-
homework?
Yeah,
You
I
backed
think,
up number 3.
and then it gives you a square, right?
No,
number 4. And it's 7.
3 doesn't, but 3 doesn't give you a square.
Oh yeah, no. 4 and I think 7 do though.
because
Do you
it's
cancel though?
Yes.
So it just puts a positive 1 on top.
Yep.
Okay.
squared, and then
And then the back is test prep.
there's a 1 on top. So you already got
Aren't your answer?
So it's just
Were
gonna-
the first 3 and